very much Principal Candice for taking the time to speak to us about our planned mini unit for digital technologies.
No, thank you, Cindy and Courtney. It's always wonderful when teachers bring new ideas to the table to improve our teaching practices. So tell me, what have you planned?
We have planned a small 5-lesson mini unit for the years 3 to 4 curriculum involving coding and the We Do 2.0 kits that our school has recently purchased. We're excited to utilise these kits as we've read many teaching articles that emphasise the effectiveness of LEGO robotics as an educational tool in the development of problem solving and higher order thinking skills.
We believe this unit provides wonderful interactive opportunities for students to develop their understanding and skill set within the digital technologies curriculum. The unit offers a constructivist learning environment which provides real-world links and caters for diverse student needs.
Throughout each lesson, there are many opportunities for students to extend their critical thinking and personal and social capabilities. The unit is structured through the gradual release of responsibility model and aims to scaffold and extend students' learning with the aid of collaborative tasks and peer mentoring.
Brilliant. Digital technologies is such a new curriculum content and so few teachers feel confident in their ability to teach it, that learning from those who are confident will go a very long way. What activities have you planned?
Begins with an introduction to coding with students exploring a variety of digital technologies and how they work, what they do and what they have in common.
Then the term coding is explained to students through the utilisation of an engaging video. The class then creates a mind map to identify devices that require coding that we use in our everyday lives. New concepts and related vocabulary words are then added to the classroom wall for the students to refer to and build upon throughout the unit.
Excellent. I like the sound of that. We all know the importance of engaging students with real-world problems to allow them to make visible connections between life and school. So, where does robotics come into this?
Prior to students' exploration of the We Do kits, it is vital that they first understand computational thinking, coding language and the importance of sequencing.
We have chosen to introduce this understanding through various unplugged activities that introduce students to terms and uses of algorithms, codes and pseudocodes. The first activity being the teacher robot, wherein the students have to direct the teacher using clear instructions to make a breakfast dish. Through this activity, students quickly gain an understanding of the importance of clear, literal codes and sequencing codes in order.
Students then engage in a cup stacking activity where they all have opportunities to deliver and create codes and to better understand how a robot or digital device reads codes.
I've seen that cup stacking activity done before. I really think the students will find it engaging and interesting.
Move on to another unplugged activity using the grid squares with mixed difficulty challenges.
After the students have a basic understanding on coding, we move on to the We Do kits. First, students build Milo the rover and program him using the iPads. Once students have mastered this activity, there are opportunities for them to show their understanding of coding by creating a fan and programming it.
The most important part of this lesson is that students are recording the steps taken to build and program their fan to create an algorithm that will be used by another group in further lessons.
Fantastic! I like how you've integrated coding into a design challenge. What a brilliant way to integrate the two technology subjects. So tell me, where does all of this fit into the curriculum?
Firstly, it covers knowledge and understanding as students identify and explore a range of digital systems for different purposes. Secondly, it covers the processes and production skills as they define simple problems and follow a sequence of steps and decisions to solve the problem. They will also be implementing simple digital solutions with algorithms involving branching and user input.
Excellent, thank you Cindy. Now, how about the general capabilities?
There are clear links to critical and creative thinking as the students are problem solving, and there are also links to personal and social capability with the high level of group collaboration and class discussions.
Does the unit link to any other subjects aside from digital technologies?
Clearly, the unit is very STEM focused. However, there are links to English with the high level of discussion and collaboration. There is also a focus on decoding new vocabulary and reading and writing code.
Mathematics is also linked with both of the unplugged activities as they give and follow directions.
You mentioned earlier that this unit caters for diversity. What strategies do you plan to implement to achieve this?
Entering through the use of heterogeneous grouping, providing information in a range of modes, for example, written, visual and audio. Then the unit is also carefully sequenced to scaffold learning throughout the activities.
In each of the activities there are also extension opportunities as well as activities that range in complexity. Throughout the unit, the teacher monitors student progress and provides opportunity for student feedback.
I'm very impressed. However, throughout all of these activities, what I really want to know is how do you plan to enhance students' understanding and knowledge of coding and computational thinking?
Glad you asked. Throughout the unplugged and coding activities, students are required to read code, create code, and follow code to reach the desired goal.
For example, in the cup stacking activity, one student speaks directions to the robot, who follows the code, while one student records the code. If the directions are not clear, the robot cannot build the cup stack. This emphasizes the importance of algorithms, including every step to allow the program or robot to function.
The next unplugged activity with the grid squares reinforces this understanding of following a sequence of steps. As the students create the steps, they understand that each step is vital to the end algorithm. Both of these activities build knowledge of coding and computational thinking.
Computational thinking is further enhanced throughout these activities as they explore computer language like pick up cup, turn on motor, etc. They learn about different coding language in the forms of pseudocode and code symbols throughout all of the activities.
How about the activities with the Lego robotics? How do they extend this?
There is an emphasis on the need for a sequence of steps to complete a desired goal. In addition to this, students will be required to use problem-solving skills, analyze problems, and be creative to reach an outcome.
This is evident in the final task as students record their code. If the steps are not recorded correctly in the right sequence, then the next group will be unable to follow their codes. Again, reinforcing the importance of a clear chronological sequence of steps when creating or following an algorithm.
All of the activities lead to students developing an understanding of the thought processes involved in creating a code that a computer or robot can effectively follow.
I can see you have both put a lot of thought into this plan. I look forward to seeing it in action in our classrooms. Finally though, how do you plan to assess students' learning?
There will be formative assessment throughout in the forms of observation, questioning and recording students' work, while the summative tasks will include following and creating algorithms to solve a variety of problems. These problems range in complexity, allow for extension, and will be assessed individually at the end of the unit.
Fantastic! You have created a brilliant new unit for digital technologies. It is very clear to me how these activities will begin to prepare our students for future learning to ensure that they will be successful in this 21st century ever-changing digital world. Thank you very much for sharing your ideas with me, and again, I look forward to seeing these lessons in action in our classrooms.